We are continuing class 11 chemistry, chemical bonding and molecular structure. We have already done the introduction. We will right away start the first concept trying to explain chemical bonding and molecular structure. The first concept is kossel-lewis approach. Year is 1916. Kossel and Lewis worked on the concept of chemical bonding and molecular structure independently and arrived at their own individual concepts. Then they joined hands and formulated a theory. We will see these points one by one. First, we will take up Lewis concept. According to this concept, atom consists of two parts, an inner part and an outer part. The inner part is kernel. It consists the nucleus and inner electrons. The nucleus contains the positive charges. Therefore, the nucleus and the inner electrons alone make it positive. The other outer part is the outer shell. It holds a maximum of 8 electrons. According to Lewis' concept, atoms attain a stable octet structure by forming a chemical bond. This octet structure is attained either by electron transfer or by electron sharing. Lewis also suggested Lewis symbols for second period elements. Let us see that: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. He used the alphabetical symbols and along with that he represented the valence electrons, that is the outermost electrons only. So lithium has 1 electron, beryllium has 2 electrons in the outermost shell, boron has 3, carbon has 4, nitrogen has 5, oxygen has 6 electrons, fluorine has 7 electrons, and finally neon has 8 electrons. Neon is a noble gas. Now we will see the significance of Lewis symbols. The dots represent the valence electrons, and this helps to calculate the common or group valence. The group valence is either equal to the number of dots in the Lewis symbol or equal to 8 minus the number of dots in the Lewis symbol. I will explain. Lithium belongs to first group, beryllium belongs to second group, boron belongs to third group, and carbon belongs to 14th group, nitrogen belongs to 15th group, oxygen 16th group, fluorine 17th group, and neon 18th group. I have followed the groups referred to in the modern periodic table. That will be more easy to understand. How do we calculate the group valence? First group elements have 1 electron in the valence shell. So, its valence is equal to 1. For the second group, for beryllium, there are 2 electrons in the valence shell. So, its group valence is 2. Similarly, for boron, it is 3. For carbon, it is 8 minus 4 equal to 4. Then, for nitrogen, it is 8 minus 5 equal to 3. Then, for oxygen, it is 8 minus 6 equal to 2. And for fluorine, it is 8 minus 7 equal to 1. And for neon, it is 8 minus 8 equal to 0. We know the noble gases belong to 0 group. So, this Lewis symbol helps to understand the group valence. I hope it is clear. Now, let us see the contribution of Kossel. His contribution is commonly called Kossel postulates. There are some 4 postulates mentioned in your textbook. We will see that. The first postulate says that In the periodic table, the highly electronegative halogens and highly electropositive alkali metals are separated by the noble gases. I will explain. In the periodic table, halogens belong to 17th group and alkali metals belong to the first group. The 17th group and first group is separated by the 18th group, which constitutes the noble gases, that is 0 group. The second postulate says that halogens being highly electronegative gain electrons and form negative ions, whereas alkali metals, which are highly electropositive, lose electrons and become positive ions. The third postulate is by losing or gaining electrons, they attain noble gas electron configuration. That is 8 electrons in the outermost shell. The 17th group elements we have seen have 7 electrons in their outermost shell, and when they gain 1 electron, they attain the corresponding noble gas structure with 8 electrons in the outermost shell. Similarly, alkali metals, they have 1 electron in their outermost shell. So when they lose 1 electron, the next inner shell becomes the outermost shell and it comes to contain 8 electrons. That is noble gas electron configuration. The fourth postulate says that the negative and positive ions formed are held together by electrostatic force of attraction. I will explain that with the help of an example. Say for example, sodium chloride. Let us see the formation of sodium chloride. Sodium atomic number is 11. When it loses 1 electron, it becomes sodium ion. How can we represent the electron configuration of sodium? We can represent it as neon, 10 electrons. Then 3s1. That makes the electron configuration of sodium. For neon, atomic number is 10. When sodium loses 1 electron, it has only 10 electrons there. Then that is equal to the electron configuration of neon. So, sodium atom has become sodium ion and it has attained the electron configuration of the noble gas neon. That is stable octet structure in the valence shell. Similarly, chlorine atomic number is 17. It gains 1 electron and becomes chloride ion. That is, it attains 1 negative charge. How can we represent its electron configuration? The electron configuration can be written as neon that consumes 10 electrons. Then the remaining 7 electrons. 3s2, 3p5. That is the electronic configuration of chlorine. This accepts 1 electron and the atomic number becomes 18. How do we represent that? Neon 10, then 3s2, 3p6. So when chlorine accepts 1 electron, attains the electron configuration of argon, another noble gas. So we may say sodium by losing 1 electron attains the structure of noble gas neon. Chlorine by gaining 1 electron attains the configuration of another noble gas, that is argon. So they become stable. This is as per the postulate. So we can write sodium ion plus chloride ion becomes sodium chloride molecule. Sodium has positive charge and chlorine has negative charge. When the molecule is formed, it becomes neutral. Sodium chloride. The total number of protons and electrons become same. From this, we can understand the electrovalence of ion is equal to the number of unit charge on the ion. So here, for sodium, the unit charge is 1. So its electrovalence is 1. For chlorine, its electron valence is also equal to 1. Let us take another example, calcium chloride. How do we write calcium chloride? CaCl2. Calcium belongs to second group. Therefore, it will lose 2 electrons. That means it will have 2 positive charges on it. So, its electrovalence will be 2. Here, it has to combine with 2 chlorine atoms because each chlorine atom can accept only 1 electron each. So, 2 chlorine atoms will accept 1 electron each. Both the chlorine atoms will have 1 negative charge each. Therefore, the electrovalence of chlorine is 1. So, what does this tell you? If you don't have an idea of this electrovalence or valence in short, it will be very difficult for you to represent the molecules of various compounds. The language of chemistry itself is to write the names of compounds as per molecular formula. CaCl2 is the molecular formula of calcium chloride. NaCl is the molecular formula of sodium chloride. There are so many compounds like this. So, it is always better to have a concept regarding this valence. Otherwise, you will find it very difficult to learn chemistry. The easiest thing is to have these basic concepts ready within your mind. That will help you a lot. Based on their individual works, they put together their concepts and formulated a theory which is called theory of chemical bonding. And from this, you get octet rule. So, we will learn these two. A question may be asked, what is the theory of chemical bonding? Who postulated this theory? State octet rule. Such questions may be asked. So, we will just see that according to this theory, atoms can combine either by transfer of valence electrons from one atom to another or by sharing valence electrons in order to have an octet in their valence shell. This is called octet rule. So, the statement of the theory and the octet rule are one and the same. So, if you learn this statement, you cannot use your own words. You have to give it the words of the scientists. So, better follow the words that are given in the text for safety. Before we conclude this topic, we will just see the merit and demerit of this theory. That is the concept of kossel-lewis. The merit is that this theory helps to understand ionic compounds like sodium chloride, calcium chloride, etc. But all the various compounds that exist do not fit into the concepts that are given by Kossel and Lewis. That is the demerit. So, it has one merit and one demerit. So, naturally, more scientists work on this and come forward with their own concept. The next concept we will see in the next video. I hope this video was of great use to you. If you think it was useful, consider supporting me by subscribing to my channel. Like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. We will meet in the next video with the next important concept. Till then, bye. Take care. Good luck.